Alright, welcome for the Lesson 7 review. Let's take a look here at Level 1. Level 1, blank, is the total three-dimensional space a figure occupies. Well, three-dimensional space, that's going to be volume. And something is the total area of the walls of a prism. Notice it just says walls. It doesn't say walls and bases. So if it's just the walls, we're talking about the lateral area. Remember the los lados. Lateral area. Blank is the total area of the walls and bases. Here we have the walls and bases, so that would be everything that is the surface area. A blank is a two-dimensional representation of a prism. That would be a net. This is a triangular prism. You know it is a triangular prism because it's made of triangles, one triangle with another one parallel to it. Although the other one's hidden, it's right back there. This is like a prism too, except for it's made of circles, so we don't call it a circular prism. We call it a cylinder. This is a rectangular prism, just like our triangular prism, except for instead of being made of triangles, it's made of rectangles. This is a cube. You can tell it's a cube. The difference between a cube and a rectangular prism is a cube is made of all squares. Everything's the same. All squares, not rectangles. So that makes it a cube. Okay, next. This one. First thing it says is name. Well, the name is clearly the same as this. So I'm just going to put TP for triangular prism. Now we need to find X. Well, X is this distance here. Clearly this triangle here has to be congruent to this one here, so this is also X. Meaning we have a Pythagorean triple for this triangle. So 6 squared plus 8 squared equals x squared. That's 36 plus 64 equals x squared. That's 100 equals x squared. So x is going to equal the square root of 100 or 10. Okay, the base of a triangular prism is a triangle. The answer is triangle. Very simple. Area of the base means the area of the triangle. So 8 times 6 divided by 2. 8 times 6 is 48, divided by 2 is 24 units squared. The perimeter of the base is going to be the three sides of the triangle added together, because perimeter means distance around. So 6 plus 8 plus 10. 6 plus 8 is 14, plus 10 is 24. This time it's 24 units because, again, perimeter is a distance. It's one-dimensional. Lateral area. Okay. The way we can do the lateral area is you take the perimeter of the base and multiply that by the distance between the bases. So the perimeter of the base, this distance here, is 24. And the distance between the bases, in other words, the distance from the front triangle to the back triangle, is 4. So 24 times 4 is 96 units squared. The surface area is going to be equal to the lateral area plus the two bases. If the base is 24 and we have two of them, then two of them make 48. 48 plus 96 is 144 units squared. And last, volume, you take the area of the base and you multiply by the distance between the bases. So the area of the base is 24, the distance between the bases is 4, so 24 times 4 is 96 units cubed. Just to review, lateral area means perimeter times distance between. Surface area is lateral area plus two bases because we have two bases, and volume is area of the base times the distance between the bases. Alright, this next one's going to work just like that one, only it'll be simpler. This is a cube, and the base of a cube is a square, and the area of the base will be 9 units squared because it's 3 times 3. The perimeter of the base will be 3 plus 3 plus 3 plus 3, or 12 units. The lateral area will be the perimeter of the base, which is 12, times the distance between the bases, which is 3. 12 times 3 is 36 units squared. Remember, all area will always be squared, just as all volume will always be cubed, just as perimeter will always be units. Okay, the surface area, well, it's the lateral area plus 2 of the bases. So if the base is 9, then 2 of that will be 18. 18 plus 36 is 54 units squared. And the volume will be the area of the base times the distance between the bases. Well, how far from the front square to the back square? Also 3. 3 times 9 is 27 units cubed. And that's that for the cube. Let's move on to the back side here. Alright, so we have to make a net of this triangular prism. So consider that what we have basically is a floor piece, a back, a top, and then 2 bases. So I'm going to start with the floor, and the floor is going to be 3 by 12. So it's going to be 3 this way, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 this way. So that's the floor piece. The back piece goes 5, so I'm going to go 1, 2, 3, 4, 5 this way. The front piece is going to be this. So it's Pythagorean theorem. So it's going to be 5 squared plus 12 squared equals x squared. That's 25 plus 144 equals x squared. 25 plus 144 is 169 equals x squared. So x is going to equal 13. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So see, this represents this. This represents this. And this represents this. And then we have these triangles which fold out like wings. So how far do they fold out? Well, this height. So in other words, this has to go 1, 2, 3, 4, 5 to there. And then it's a straight shot over to there. This distance again will be 13 because it's the Pythagorean theorem with 5 and 12. So this will be congruent to this. This will also be 1, 2, 3, 4, 5. And then there. So again, this is 5, this is 13, this is 12. So this is our net. As we already discovered, x equals 13. So in a net, the easiest way to figure out the lateral area is it's the sum of the non-bases, in other words, the walls. So this one is 5 by 3, so it's 15. This one is 3 by 12, so it's 36. And this one is 3 by 13, so it's 39. If you add these together, it gets you the 3 walls without the bases. So 36 plus 39 is 75, plus 15 is 90. So it's 90 units squared. Surface area, again, is the lateral area plus the 2 bases. If these are both 5 by 12, then that's 60, but 60 divided by 2 because they're triangles. So this one is 30, this one is also 30. Add them together, that makes 60. 60 plus 90 is 150 units squared. And last, you have the volume. Well, that's the area of the base, which in both cases is 30. So 30 times the distance between the bases, which is 3. 30 times 3 is 90, and in this case it's units cubed because volume is always cubed. Okay, construct a net of a hexagonal prism. Okay, I'm not going to actually construct it because that would be very time consuming. I'm just going to do a quick sketch of it. So there's a hexagon. As you can see, the side length of the hexagon is 3, so we'll make these all 3 centimeters. And then we've got this net. Well, this has a height of 2, so it goes down like this. So this is 2, this again is 3, because it's the same as this. And of course we're going to have 6 of these, because it has to be enough to stretch all the way around the hexagon. 1, 2, 3, 4, 5, 6. And they're all going to be 3 on a side. They have to be because they're all congruent because it wraps around the outside of the hexagon. And the height will always be 2 because that's the distance between the top hexagon and the bottom hexagon. Alright, and then we'll have another hexagon down here. Alright, so there's your net. It's a sketch, of course. I'm not going to construct it. It takes too long and you wouldn't really want to watch it. Alright, the lateral area will be the sum of the non-bases. In other words, these ones. Well, if this is 3 and this is 2, then this is 6, 6, 6, 6, 6, 6. Because it's just base times height. And there's 6 of them. So 6 times 6 is 36. What are we talking about? Centimeters. Centimeters squared. Surface area is going to be the area of these 2 hexagons added onto that. So this is a little tricky. Let's take a close-up view of one of the hexagons. If you take this as a triangle within the hexagon and this is 3, that's S. S divided by 2, so 3 over 2 squared, square root of 3. This is going to get us the triangle, and then we have to multiply by 6 to find the hexagon. So 3 over 2 squared is 9 over 4. Again, that means 3 squared is 9, 2 squared is 4. So 9 over 4 square root of 3 is the area of a triangle. And again, how many triangles do we have in our hexagon? 1, 2, 3, 4, 5, 6. So what we do is we multiply by 6. That gets us 54 over 4 square root of 3, which reduces to 27 over 2 square root of 3. So this is 27 over 2 square root of 3. Now I have 2 of these, right? So if I add them together, that's 54 over 2 square root of 3. And if you realize that 54 over 2 just reduces to 27, then our actual area of the two hexagons together is 27 square root of 3. So what we get is 36 plus 27 square root of 3 in parentheses centimeters squared. Yep, this is a level 4. Alright, last, volume. It's the area of the base, in other words the area of the hexagon, which we found right here, times the height, and the height is 2 centimeters. So 27 over 2 square root of 3 times 2 over 1, well obviously those will just cancel out, leaving you with 27 square root of 3 centimeters cubed. Cool. That's it. That's all of lesson 7, from the easiest to the hardest. Good luck. Thank you.